Today, to put things in a historical context, I'll go through and outline the requirements of the unified field theory, what the unified field theory needs to do, and why it has been so difficult to try and find it in the past. Number one, the first requirement, it must be simple. It must be simple, straightforward, and easy to understand pretty well by everyone. Number two, it should be all-encompassing. So it's got to include all physical events and describe all physical events, but at the same time be quite simple. Number three, this is what I call the left field requirement. It's got to come out of left field. In other words, it will completely sort of blow the status quo out of the water. It will usually come from someone who is not within the scientific community, but at the same time has the acumen to be able to find the mathematics that are necessary and to know enough of the physics to be able to meet these two requirements from the beginning. So basically, it should come out of left field or be something that is a major breakthrough or something completely new or different. Number four, in spite of the fact it's got to come out of left field and be contrary to the status quo, it has to basically validate previous scientific theory. For example, when the Einstein field equations came through, Einstein did validate Newton's theories under certain conditions, and then under other conditions the general relativity effects would explain other values that Newton could not. In the same way, if something comes up, it has to validate everything that's happening within quantum mechanics, within electromagnetism, and with gravity, and it also will be totally against the status quo, all-encompassing and simple. And number five, this requirement basically comes from Mr. Thorne and Wheeler's book, Gravitation. It's MTW's Gravitation, in which it's a very good book explaining the requirements of the unified field theory. And this one says that you've got to be able to derive the Heisenberg uncertainty postulate from Schrödinger's equation. This has been done before, so if you can derive, basically what I found is there's other ways that you can get to the unified field theory. This I had done sort of afterwards, but I'm finding the best way to explain the unified field theory and how to get to it is primarily that we can start here. We can derive Heisenberg from Schrödinger. After we do that, we can then validate all the previous theories. It will be completely contrary to the status quo. It will be all-encompassing, so it will describe all physical events, and it will be remarkably simple and able to be understood by everyone.